Hey everyone, in this lesson we're continuing with preprocessor tools. In the previous lesson we covered all the directives. This time we're going over all the operators. A preprocessor operator is a special construct recognized during the preprocessing stage. It's not part of C++ as an execution language. It's handled by the preprocessor and it's used either in preprocessor expressions or during macro expansion. That might sound intimidating, but in practice it's just a specific set of symbols used alongside preprocessor directives to get certain things done. Don't confuse C++ language operators with preprocessor operators. Let's break them down. The first preprocessor operator is defined. Remember the if-def directive? You can write if defined macro name instead. It works exactly the same, but it's easier to read. On top of that, you can combine this operator with regular C++ operators to build more complex checks for whether macros are defined. Defined is a unary preprocessor operator that checks whether a macro exists at the moment the directive is being processed. It's only used inside if and elif directives. There are two forms, with parentheses and without. Since it's an operator, it has to produce a result. If the macro exists, it returns 1. If it doesn't, it returns 0. It doesn't check the value of the macro. So if a macro exists and is equal to 0, defined still returns 1. It only cares about whether the macro is defined. Here are a few examples. In the first one, if debug mode is enabled, we include this block of code. Using defined makes the condition clearer. In the second example, you can see how I use it to check which platform I'm currently on. In the third example, I combine multiple conditions, whether debug is defined and debug is not defined. In the fourth one, I'm using a slightly different condition. Bottom line, this operator lets us check for macro existence in a more expressive way and write more complex conditional expressions. Let's move on to the next operator, underscore underscore has underscore include. This operator checks whether the include directive can actually find a given file. Just like defined, it's only used with if and elif directives. It has two forms, using angle brackets and using double quotes. Inside, you specify the file name you want to check. If it returns 1 if the file exists and can be included, and 0 if it can't. The difference between angle brackets and quotes is the same as with headers. We'll cover that in a few lessons. Angle brackets mean look in the standard library. Double quotes mean look in the current project first, and if it's not there, then check the standard library. Here's a typical example. If the optional header from the standard library is available, we'll talk about it much later, we include one block of code. Otherwise, we fall back to something else. Next up is the underscore underscore has underscore cpp underscore attribute operator. It checks whether the compiler supports a specific attribute. You don't know what attributes are yet. We'll cover them in detail in future lessons, but I'll still show you an example here. Just like the previous two, this operator is only used with if and elif. The syntax is straightforward. Write underscore underscore has underscore cpp underscore attribute and put the attribute name inside parentheses. The key difference is that it doesn't return 1 if the attribute exists. Instead, it returns a number in the format year plus month, representing when that attribute was standardized. In the first example, I'm checking whether the noDiscard attribute exists. This attribute is placed before a function definition. It tells the compiler to issue a warning if the programmer calls the function but ignores the return value. And here you can see that warning in action. If the compiler didn't support this attribute, we could add an else branch and handle it some other way. In the second example, we're actually checking the value returned by this operator. As a reminder, it returns the year, 4 digits, and the month, 2 digits, when the attribute was introduced. Over time, this attribute was improved. We got the ability to pass a custom message, so the compiler shows the specific text in the warning. Here, we're checking the version of the attribute. If it's newer than July 2019, that means it supports custom messages, so we use that form. Otherwise, we fall back to the basic version of the attribute. We're done with conditional compilation operators. Now let's move on to ones used in macros. There are two of them, the single hashtag and the double hashtag. The single hashtag takes a macro argument and returns it into a string by wrapping it in double quotes. In other words, it converts the argument into a string literal. Let's look at the first example. We define a macro str that takes one argument and immediately returns that same argument as a string literal. Basically, it just wraps it in quotes. Then we include iostream so we can use cout, and you can see me calling this macro a few times. First, I pass it just the text hello. At this point, it's just plain text, so the operator wraps it in quotes and we see hello printed on the screen. No quotes in the output, but internally it became a string literal. Next, I call the macro with 123 plus 4. And what we see on the screen is literally 123 plus 4. Why? Because the preprocessor doesn't evaluate expressions. It just sees the sequence of characters 1, 2, 3 plus 4 and wraps it in quotes. So that exact text gets printed. Then I pass A plus B. We don't even have such variables or constants defined, just like with hello earlier, but that doesn't matter. The preprocessor treats it as raw text and wraps it in quotes, so we see A plus B. Finally, I pass in an actual string literal. Even then, it still wraps the whole thing in quotes again. So what we get is a string that literally contains quotes inside it. The preprocessor doesn't care. It just takes the token sequence and adds quotes around it. In the second example, I define a macro lock that takes one argument. It expands into a piece of code that prints the argument as text, then prints equals sign, and then prints the value of that argument. Let's see how it works. We create a variable a equal to 5. Then I call the macro with a plus 3. The preprocessor replaces the macro call with the expanded code. So a plus 3 appears once as a string literal because of the hashtag operator, and once as a normal expression that the compiler evaluates later. In the last example, we define a macro enum to string that takes one argument and expands into this piece of code. It's part of a switch statement. Let's see how we use it. We define an enum weekday with values like Monday, Tuesday, Wednesday, and so on. Then we write a function weekday to string that takes a value of this enum, then returns a string. So if it's Monday, it should return Monday in double quotes, and so on. Inside a function, we use a switch statement to check the value. We also write using enum weekday, so we don't have to prefix each enumerator with weekday and so on. Then we call the macro 3 times. Each call expands into a case that returns the string version of the enum value. So this is basically a small shortcut that lets us conveniently convert enum values into their string representations. In main, we call this function with Monday and we get Monday printed on the screen, not the underlying integer value like 0, but the actual name as text. That's how this operator works. It just wraps whatever you pass into it in double quotes. And finally, let's talk about the last operator, the double hashtag. This is a preprocessor operator that concatenates 2 tokens into one during preprocessing. Just like the previous ones, it's only used inside defined macros. It literally takes 2 sequences of characters and glues them together, producing a single token. Here's the first example. We define a macro var that takes one argument and returns a combination of the word var, an underscore, and the argument. Then in main, we use it like this. We create a variable named var count. We pass count into the macro and it expands into var count. That's how we end up with that variable name. In the second example, we define a macro makeInt that takes 2 arguments and simply concatenates them. In main, we call it with 10 and 20 for the preprocessor, these aren't numbers, they're just tokens, so it glues them together into 1020. Then the compiler treats that as a number and the program outputs it. I could go a lot more edge cases and subtle details about these macros, but I want to keep this focused and not overly complicated. At this point, you've got a clear understanding of how all these operators work. They're actually pretty simple in what they do, so we'll leave it at that. In the next lesson, we'll wrap up the preprocessor and take a look at predefined macros. That's it for this lesson. Thanks for watching. If you enjoyed the video, you can leave a like, drop a comment, subscribe to the channel if you haven't already, become a channel member to get access to practical lessons, or support me via the link in the description or through YouTube's thanks feature. See you in the next lessons. Goodbye.